Again, you'll see what is the concentration of a solution in parts per billion if a certain number of grams of lead is dissolved in a certain number of grams of water. This time 1 part per billion, and I'll personalize it, 1 part per billion lead, lead is what's dissolved in the water, is going to be equal to 1 times 10 to the minus 9th grams of lead per milliliter of water. So a part per billion is like 1 times 10 to the minus 9th, which is 1 billionth of a gram per milliliter, where a part per million had the 10 to the minus 6 here. So to work this problem, we're going to actually find our grams per milliliter. I have my grams. Oh, and let's see. Just to let you know, on your conversion and equation sheet, we do have parts per million right on it. This is the first page, which has all those equations on it. So if you go to the bottom, there is parts per million. So in addition to molarity and a couple other concentrations and formulas. Anyway, so that's available to you. We don't have parts per billion on there, but it's similar enough. So now, remember, my 3,050 grams of water is 3,050 milliliters of water. And so I'm just going to multiply this out. 0.0000658 divided by 3,050. I get 2.16 times 10 to the minus 8th. And that's grams of lead per milliliter of water. And now I'm going to use this equal statement up here. Any two things that are equal can be put above and below each other in a unit conversion factor. So I'll put this part on the bottom. And I'll put my 1 part per billion lead on top. And I sort of wrote that kind of big, but let me see if I can write my answer up here. So it's going to be 2.16 times 10 to the minus 8th divided by 1 exponent 9 minus, and I get 21.6 parts per billion lead. And so Blackboard will have no trouble taking the number 21.6, which is what you have to put in for this problem. Any questions about that?
Professor, the calculator, please.
Sure thing.
Thank you.
Yeah.